Despite being the closest planet to the Sun, Mercury is not the hottest. This honor actually goes to Venus, which happens to be the second planet from the Sun. Now, how is it that Venus is both further away from the Sun and still hotter than Mercury? This is Cup of Science Joe, and that question right there is only part of why we are here today. Now, the answer to this, in short, lies in the thick atmosphere that Venus has. Now, here on Earth, our average surface temperature is around 60 degrees Fahrenheit, and less than 1% of its atmosphere is made up of CO2, among a lot of other things. Now, this CO2 acts as a greenhouse gas, by doing so absorbing some of the heat into the atmosphere that would have otherwise escaped back into space. This now trapped heat remains in the atmosphere of the planet, causing it to be warmer than it would have been in the absence of the CO2. Now imagine for a moment what this would be like if the Earth had around 2,000 times as much CO2 as it does now, and this right here is what brings us to Venus. Venus is not only closer to the Sun than the Earth is, but it far outpaces us in the greenhouse gases found in its thick atmosphere. So, it is no wonder that with all that trapped heat, the entirety of its surface is around a scorching 870 degrees Fahrenheit. To go back to Mercury for a bit, its surface, on the side that the Sun is hitting it, reaches around 800 degrees Fahrenheit. The side that the Sun isn't hitting cools down quite a bit more because of its lack of an atmosphere. Now that we are here, why don't we talk some more about the second planet in our solar system? Venus, and we kind of mentioned this earlier, is a cloud-covered planet that is named for a goddess of love, and it is often referred to as Earth's twin. But if we take a closer look, it really starts to seem more like the planet is the Earth's opposite. Venus has some interesting traits. It spins backwards, and has a day that is longer than its year, and it also lacks any real semblance of seasons. It may once have been a habitable ocean world, but that would have been at least 1 billion years ago. The runaway greenhouse effect we talked about earlier has long since evaporated all of its surface water, allowing it to slowly leak into space. All that's left behind now is volcanic rock, created by the extremely high temperatures and pressures found on the planet. So if we were to ask if Venus could harbor life at this point, well, the answer to that would be a definite no. Or at least on the surface, that is. While this may sound unrealistic, the temperature, air pressure, and chemistry high up in the clouds just might provide conditions that some form of extremophile life could form or exist in. By studying Venus more, we may even be able to learn lessons about what it takes for life to get a start, like it did on Earth, or like how it could elsewhere in our solar system and even across the galaxy. This is because even if they are gone now, Venus most likely once held all of the ingredients needed for life. It is a very hard planet to study, though, because while we can orbit it, the clouds kind of prevent us from peering too far inside, and due to the intense temperature and pressures I mentioned earlier, any spacecraft that may land there doesn't really have a lot of time available to it to perform science. The longest anything has remained on the surface was for a little over 2 hours. This was achieved by the Soviet Union's Venera 13 probe back in 1981. Let's have a look at some of the pictures of the surface that we gained from this mission and a couple other of the Venera lander missions as well. Now, what Venera did to get these was scan the surface back and forth to create the panoramic images of their surroundings. They revealed yellow skies, cracked and desolate landscapes that really looked both alien but also possibly familiar. Views of a world that, like I mentioned earlier, may have once been similar to Earth. Several attempts have actually been conducted, though, by the USA, Japan, and the aforementioned Soviet Union. Enough about the past, though. Looking forward into the future, both NASA and ESA have upcoming missions for Venus planned. NASA having 2 orbiters, the DAVINCI mission and the Veritas mission, and ESA with the Envision mission. I also believe Envision is going to be an orbiter as well. Now let's talk about those first 2 missions just a little bit. DAVINCI stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. This mission will help us measure the composition of the atmosphere of Venus to help understand how it formed, evolved, and to determine if the planet really did ever have an ocean. This mission, along with its orbiter, will have a descent sphere that will plunge through the thick atmosphere, making precise measurements along the way. And Veritas. This one I might butcher, but we'll see. This one stands for Venus Emissivity Radio Science INSAR Topography and Spectroscopy. So a lot of stuff going on there that may merit its own video. This mission will help us map the surface of Venus and help determine the planet's geologic history and better understand why it developed so differently from Earth. It will do this by charting surface elevations over nearly the entire planet to create a 3D reconstruction of its topography, among other things. Each of these 3 missions are slated to launch later this decade or in the early 2030s. And personally, I feel these missions are important not only because they will help us continue to study Venus itself, but they really may also help teach us about the direction Earth could be going as well. Given the current state of global warming, I fear that if we continue the way we are going, Earth may someday, in a distant future, go the way of Venus, and, probably by fault of our own, experience a runaway greenhouse gas effect that prevents both humanity, but also all the other living species from continuing to exist and thrive on our planet. Granted, this would take a very long time. My hope, though, is that by studying both what we see going on here on Earth, along with studying things in space, such as with the planet Venus, we can gain more tools and knowledge to use at our disposal for helping to stop and maybe even reverse the effects of global warming here on Earth. Granted, it's not just enough to learn what we can do to help improve things. We must make use of and implement that knowledge as well. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.